Okay, so this is the last video from the Chapter 2, Part 2 notes. The examples, anyway. So this is examples 6 and 7. The first one we have to solve analytically, which basically means show all your work, do it algebraically, don't just use the calculator graph or anything like that. So in this one, we care about when it's less than or equal to 0. I'm going to call this side, so that I have something to refer to it as f of x. So f of x is this. So one thing that would come in handy is if I combine these fractions first. And before I do that, let me list the domain over on the side, because that's always good practice. X can't be 1 from this part, and x can't be -3. Let me put the -3 first. -3 and 1. Okay. So if I combine the fractions, I'm going to multiply the first one by x minus 1 over x minus 1. So I get 5x minus 1 over x plus 3, x minus 1. And I got to multiply the second one by x plus 3 over itself. So I get x plus 3 on top over the original x minus 1 times x plus 3. And I care about when this guy is less than or equal to 0. So at this point, I can combine the two on this side. So this turns into 5x minus 1. I'm going to distribute the numerator. So it's 5x minus 5, and then plus 3x plus 9. And the reason I put these in parentheses is because if this was a minus right here instead, you'd have to distribute that negative. And I've noticed up to this point in the year, anytime that comes up, a lot of people have forgotten to distribute the negative. So the denominator is the same for both x plus 3, x minus 1. And that's going to be less than or equal to 0. Okay. Don't make the mistake of multiplying that denominator over, because you don't know if the denominator, depending on the value of x that you pick, the denominator might be positive and it might be negative. And depending on if it's positive or negative, when you multiply both sides by it, that could flip this sign. And since you don't know what it is, you just don't want to deal with it. So instead, this is still f of x here. So we're going to make a sign chart for f of x and just see when it's less than or equal to 0. It's just like a graphing problem, except we're not going to bother with the graph. We're going to stop at the sign chart. So let me simplify f of x a little bit more. That's going to be 8x plus 4 over x plus 3, x minus 1. And I'll even factor out the 4 here. So it's 4x plus 2. Or sorry, x plus 1. 2x plus 1. Over x plus 3, x minus 1. And we're checking when is this less than or equal to 0. Okay, so we can figure out from this, f has an x-intercept, or let's just do zeros. F has zeros, a 0, just 1, when the numerator is 0. So that's when 2x plus 1 equals 0. I'll do this on the side. 2x plus 1 has to be 0. So 2x is negative 1, so x is negative a half. So it has a 0 at x equals negative 1/2. It's got vertical asymptotes when x is negative 3 and when x is 1. And it has no removable discontinuities because nothing in the denominator cancels here. So when we make our sign chart for f, I'm going to put my removable discontinuity, negative 3, or sorry, not removable, vertical asymptote, negative 3 and 1. And I'm going to put my 0 at negative a half, 0. And if you do a sign chart for this, I'll just tell you what it's going to be. You can plug in test values, but you get negative here, you get positive, you get negative, and you get positive again. Okay, so we were checking when f of x, what we called f of x, that has to be less than or equal to 0. And that happens when I've got these negative signs. So that happens here and here. Okay, so let's write this out. That happens when x is in this range, or this domain, let's say, when it's in the interval from negative infinity up to negative 3. And you don't include the negative 3 because it's not a 0, it's actually undefined there. Union. And then I do include the negative a half because it is 0 right there. So negative a half up to 1, but I don't include the 1 because it's a vertical asymptote. It's not defined there. Okay, so here's the answer right there. Hope that helps. And then let's do example 7. Okay, so 7, it's a little bit uglier. So let's write out our domain first. The denominator tells us x cannot be 2. And the numerator, this part right here, we know that x plus 1 has to be greater than or equal to 0. So that tells us that x has to be greater than or equal to negative 1. So I also have this, x has to be greater than or equal to negative 1. Okay, so really you could think of the domain as this. It's, let's see, it's everything from negative 1 up to 2, union 2, and on. All right, so let's look at our zeros here. This is already in factored form. I don't know why I erased that. Let's undo that if I can. Oh, I have no idea what I'm doing. I don't know where the undo button is. Oh, there it is. What's going on? There it is. All right. Okay. I'm not going to redo this video. Sorry about that. All right. So let's, since it's already in factored form, I'm going to call this thing right here f of x. So the zeros of f are going to happen when the numerator is 0. So that's at x equals 3 and when x equals negative 1, which is allowed because it's in my domain, and so is 3. I know that I get a vertical asymptote at x equals 2 since the denominator doesn't cancel with anything in the numerator. And I have no holes in there because nothing else in the denominator cancels. There's nothing else in the denominator. Okay, so if I make my sign chart at this point, normally I'd make a sign chart that looks like this. But I'm not actually going to have the arrow keep going in that direction. I'm going to chop it off here at negative 1 because I'm not allowed to have anything else beyond negative 1 here. Right? So negative 1 is where I need to chop it off. I know that I'm undefined at 2. That's going to be the vertical asymptote. 1 happens to be a 0. Negative 1 happens to be a 0. And I also have a 0 at 3. So if I plug in some test points here, I'm going to get, I'll just tell you, it's positive here, it's negative here, and it's positive here. And let's see, I need to know when when f of x is greater than or equal to 0 according to the original problem. So it's greater than or equal to 0 whenever it's positive. So that's here in my sign chart. And it's 0 right there at negative 1. And also from 3 on. So this is what I'm including in my sign chart. So my solution is going to be when x is in the domain, or in the intervals, starting at negative 1, going up to 2, but not including 2 since that's a vertical asymptote, so it's not in my domain. And then also from 3 all the way up to infinity. So there it is. There's the solution. I hope that helps.